Hey everyone, thanks for joining the workshop. Before we get started, let me try sharing my screen. Cool. Hey everyone, thanks for joining for the GraphQL workshop. My name is Nikhil Chandrappa. I'm one of the lead engineers in the ecosystem engineering team of YugabyteDB. We build a bunch of integrations around popular developer tools like GraphQL, Spring Framework, host of database drivers, schema migration. There's like a bunch of other projects we work on. And also I have today with me Eric Pratt. Eric, sorry, Pratt.
Hi, everybody. Senior Solutions Engineer here at Yugabyte. Worked with Nikhil a bit here on the GraphQL stuff. So excited for our presentation today and to talk about this stuff some more.
Awesome. Thanks, Pratt. Yeah, he is the one who kind of does everything in the production. So he has a lot of experience running the GraphQL workloads for a bunch of our customers. Okay, cool. Actually, we both are super excited today for this workshop because we are going to be running a hands-on session on our newest offering on the Yugabyte set of products. We're going to run the workshop on the Yugabyte Cloud, which was released this as probably on Tuesday, I believe. If you have been following the DSS summit, you will know a bunch of sessions around that and how easy is it for anybody to get started. So we're going to see how you can use the same for developing GraphQL applications. Cool. So as part of the agenda today, we have quite a packed session. There's a few interesting things we do. We get started by just giving an overview of what GraphQL applications brings to the table and why you need to think about using YugabyteDB for as a backend database. And how you can get started and how the integrations with Hasura and YugabyteDB works. And we follow that up with a hands-on session where we are going to set up a Hasura cloud instance and the Yugabyte cloud so that we can work with that stack. And as part of this demo workshop itself, we are going to build a real-time polling application, which is going to use this cloud or the serverless stack that we are going to use. And then we kind of transition into how you can do the tuning and performance of the GraphQL queries and do's and don'ts with GraphQL with YugabyteDB. Those are the things that Pratt is going to talk about, based on his experience running GraphQL applications using Hasura and YugabyteDB on the cloud. Cool. Before we get into what the capabilities of Hasura or the YugabyteDB itself, we all probably if you have experience working with GraphQL and or if you have heard the term GraphQL, of late GraphQL is being super popular in the enterprise world as well as startups, right? It kind of gives the application developers or the UI developers flexibility of how they can query the data from the backend. They can only retrieve only the amount of data they are looking for in the UI, and they don't have to do a lot of data manipulation on the UI itself. So it also provides a bunch of things around how you can evolve your APIs based on the UI changes rather than letting the backend developer drive those things. So that's why it's gaining a lot of popularity with the UX developers, and it is as you could see, it will be super easy to get started as well. So in any GraphQL setup, you will have something like a GraphQL provider and a backend database. In today's workshop, we are going to have a Hasura GraphQL instance connecting to a YugabyteDB cloud instance. So Hasura GraphQL engine is one of the popular open source GraphQL providers out there. We are going to see how it works with YugabyteDB to retrieve query the GraphQL, query the database using the GraphQL API itself. So it's as simple as giving a query using GraphQL or your Node.js applications and getting the data back, right? So obviously, like for anyone to get started, it is pretty simple on their workstation. Like you can if you have like Docker on your workstation, you can pretty much get started with both. Which is like super easy for somebody to start their project and quickly prototyping it. But when it comes to like handling or moving this entire setup into live traffic, right, when it takes the real user data or the user traffic, so you would have to think about how you manage like all the infrastructure that is related for hosting your GraphQL as well as your backend database, right? That's why we see a lot of developers kind of embracing cloud, right? Cloud kind of simplifies all the day two operations. Like in our case, we're going to work on a fully managed GraphQL stack. So the GraphQL engine that we are going to use and the backend database, both are like kind of one click away. Like as like with bunch of with one or two clicks, you are able to create a real world production ready like clusters or the instances of both Hasura and YugabyteDB, and you will see how we can configure those things to like develop a GraphQL application. So everything what Yugabyte kind of provides is if you have been following all our the DSS Summit sessions, you might have heard things like linear scalability and the high availability that Yugabyte provides, right? Why do we care about that, right? Like obviously, when you start small, you might have thought about like 3 months or 6 months down the line, this is the amount of traffic you are going to get. But what happens if you become viral, or if your if your mobile app or whatever, it kind of goes through the roof? So there needs to be a stack which can easily scale. Obviously, the Hasura GraphQL engine itself is stateless because it kind of maintaining all the state in the post or in the backend database itself. So there are like some of the challenges we have seen with a single node Postgres instance, where it kind of has a bottleneck of like how much scalability it can support or how much concurrent connections it can support, right? So that's why when you move to a scalable architecture like YugabyteDB, which is able to linearly scale and also it is able to handle like infrastructure outages, you kind of have an improved user experience that you are going to get. And doesn't matter how much you grow, it is like you can easily plan for how you can scale out your infrastructure easily with just click of a button. So those are some of the things we are going to touch upon today. And as part of the workshop itself, so we are going to have a hands-on session. Any questions so far before we go on to the hands-on session? The things we talked about. Cool. I don't know, Pratt, if you see any questions on the chat.
No questions yet. I'm looking.
Okay, cool. Yeah, then we can. I can proceed. Like what we are going to do today is we are going to build a real-time polling application. So the repo that we are going to use as part of today's workshop is can be found here. I'm going Pratt, if you can paste the same link on the chat for the participants, it would be awesome. Cool. So if anybody is planning to follow along, please go ahead and clone this repo. It has like steps of how it walks through the steps that we will be doing for running through this workshop. Okay, cool. Before we get to the actual repo itself or the workshop itself, I want to go through the few prerequisites we had as part of this workshop, and hopefully, you have seen these, seen some of these things. So what you will need is probably you'll need access to a Yugabyte cloud instance and Hasura cloud instance. So both these cloud offerings have a free tier support. So today we are going to show the free tier like as part of this workshop, and also as a part of the demo, I'll show you like how like the production non-free tier of the Yugabyte DB would look like. And we'll see that as we go along with this workshop. The one thing that I have done already is I have created a user for myself. I have created an account on Yugabyte Cloud as well as on Hasura, and I have went ahead and started Yugabyte DB instance for Yugabyte DB as well as Hasura here. So these are a couple of things that we had as part of our prerequisites. Hopefully you have all these things set up already. Cool. And one thing that we want to do is like we will be building this real-time polling application. So we'll not go into the how the Node.js implementation of this looks like. We are pretty much interested in how you can get started with Apollo client, configure the required endpoint for Hasura, and how you can get started, right? Those are the things that we are interested in. Cool. And if you have cloned this repository, there's like one thing that you could see. There is another file here called as workshop.md. This kind of walks through the hands-on session step by step. As I explained, the step one is for us to create the cloud instance for both Hasura and Yugabyte DB. And one of the important things that we have to do is by default, the Yugabyte DB instance will not be accepting any traffic from any other IP addresses. So what we have to do is first thing is go add for the allow IP address. So what I'm going to do is I'm going to if we go to the Hasura cloud instance, we'll see something called as Hasura cloud IP. I'm going to give access so that Hasura instance is able to connect to the Yugabyte DB database. So let me go ahead and do that first. I'm going to, and I'm going to say this, call it Hasura access, and I click on save. Yeah, it's going to take a few seconds, 30 seconds to a minute for it to get applied. In the meanwhile, let me go ahead and clone this repository so that we can get started. Okay, let me go to, hopefully this should be visible. Let's clone. What we can do is you can import the project into your IDF choice or any like graphical editor you might have on your system. Okay, I didn't want to do this. Let me go to workshop. And you'll see all the things that we have as part of this particular project itself. So, okay, let me go to the workshop. Let's see if our the IP address is applied. Okay, perfect. So there's like one other allow I wanted to do. Okay, let me quickly refresh this so that it gets reflected. List. I want to add access to my personal workstation as well. So I'm going to say detect my IP address. I'm going to save this. Okay, cool. So that's as part of our first step. Like anybody trying to access this Yugabyte DB instance from your whichever the VM or your workstation or any other app which is running on a different VM, first thing that you would want to do is configure your the IP allow list so that we have the right permission required for accessing the database itself. So once that is done, we are going to see what are the next things as part of the workshop. Cool. So the next thing is we are going to configure the Hasura cloud instance that we have here so that it can connect to the YugabyteDB cloud instance. So let's go ahead and launch the Hasura console. And after going to the Hasura console, you will and one thing that you're going to see as part of the connect thing is like when you create the Yugabyte DB cluster itself, it kind of gives you an option for downloading the credentials, which I've already done, which is needed for us when we are configuring the connection string, because it uses the username password for connectivity. So after launching the Hasura console, let's go to the data tab here. In the data tab, as you can see, there is a tab here for connecting to an existing database. In our existing database, let's give the display name as Yugabyte Cloud Instance. So the name that we give here becomes important because the Hasura requires during the migration step, the database name, whatever we give here, to be present on your the migration folder as well. So we already have pre-created a migration folder called Yugabyte Cloud Instance. That's why we are going to have the same display name. Let me get all these pop-ups out. Okay, and one other thing that I wanted to talk. So you can, if you notice, so YugabyteDB is Postgres SQL compliant. So that's why we'll be using Postgres SQL data source driver. So coming back to the step one, as you can see here, there's like few things that we want to do: retrieve the host name of the Yugabyte cloud instance and retrieve the required credentials for connecting to the YugabyteDB itself. So let me make a note of this connection string format, and I go back to my go back to my IDE, and I will get the username password here. Is admin, and the password is this. So let me quickly go back here. Oh, one thing we have to do is, which is already called out here, like the special characters that we have as part of the password itself needs to be encoded. So let me quickly do HTML encoding. Okay, let me quickly do that. Okay, cool. We got that here. Go back and put it here, and let me go ahead and get the host name for YugabyteDB. You can find the host name here and connect your application, and you can see the host name. Five, four, three, three. Okay, perfect. So that's all you will need. You'll need the username, password, as well as the host name. And let me go ahead and configure the database.
I think you missed one on your copy for the connection string. You missed the 0, I think, at the front when you're in the cloud.
Okay.
Yeah.
Oh, I think it's still not encoded. Let me quickly. Encoded. Oh man. For some reason, it is not encoding. Pratt, do you have some encoder tool with you? Let me quickly.
Yeah, let me give me 1 second, pull it up. You shoot me the password.
Yes. Yeah, in the meanwhile, there's like few things that we can do in the application itself. The thing is, as we said, I'll wait for you guys to go ahead and create these instances so that so that we can follow along the steps that we are doing while Pratt is helping us
I shot that back over
with
to you.
encoding. Okay, perfect. Let me get that connection string. Go back to here. This Q. Okay, let me quickly see what's happening. Something to do with PostgreSQL. Copy this. Right. Get the connection string. So true. Okay, cool. Is it because I'm not able to connect to the database? Let me quickly check. Okay.
Something.
Okay. And the meanwhile, what I already have is I have already like instance where we have pretty much like ran all these things already. So I'm going to use that particular instance instead of this. While probably like Pratt is going to when Pratt is doing his part, I'm going to like kind of come back and review what's happening there. In the meanwhile, in order to continue the workshop itself, like I'm going to use a setup which I already done using the same steps that we have noted here. So one thing that we are missing now is this particular step where we have to run the migrations that are required as part of running the or applying the schema that is required for this particular demo application. So what we have, if you go and see our the existing Hasura instances, so you'll see a bunch of tables that we have already applied. The schema is already applied as part of the migration step. So we have like a few tables here, and as part of this table, so we have gone and added few relationships as well for this particular database. So once once we do this step where we set up the set up the workshop or set up the Hasura instance itself, like running the migration and setting the database, the next step would for us is like tracking all the tables and relationships that are required. As I said, we have already tracked all the tables and relationship that is required. So now we'll just go to the GraphQL console of the Hasura instance. Inside the GraphQL console, you'll see a bunch of the GraphQL API explorers that you can see, or the GraphQL types at the site. And as part of our application, if you go to the graphql.js file, you'll see a host of a bunch of queries here, which are going to be used for like doing the real-time poll application itself, like how you like a few things like how to vote, like what is the mutation that we want when you click on a vote, so what happens there, and things like that. So let me quickly go ahead and run one of the queries. I'm going to see what is the current poll we are running. Let me copy the poll query here, and I'm going to go ahead and run the poll query. As part of the live poll that we are doing here is like, what is the this is the poll which we were doing. What is your favorite front-end framework? So the framework we have is React, Vue, Vanilla JS, and Angular Ember. So that is what we are. This is the poll application that we are going to run today. So before this, the UI comes up, there's like few other steps that we have to do as part of this. So we verified the setup. We see that the data is coming here. And once we have finished the verification, the next step is so going back to our GraphQL, the code base itself, and making few changes here. Inside the apollo.js file, there's like two constants we have to update. So we have to update the GraphQL engine hostname, as well as the secret that is required for connecting to the Hasura instance. So if you go to the Hasura Explorer, and you can see the GraphQL endpoint that we are going to use. So depending upon whatever the name that you have given, so that will be the GraphQL name that we are going to have. And so it's called the Hasura poll. Cool, 1 second. Let me close this. Close this. Cancel. Okay. And then the another thing that we want to do is we want to get the newest Hasura, whatever the Hasura secret we have here. Let's copy the Hasura secret and post it here. Cool. That's the only change that we want to do as part of this application. Like the rest of the things is is taken care. And the main thing that we wanted to show is like how the configuration between the Hasura and the Yugabyte cloud instance is going to happen. As you could see, like we'll come back to that. But for now, we have existing instance which actually has all those things set up. So let me go back to my database here, and I'm going to say npm start. So this is going to start my real-time polling application. As you can see, there's like few users, and there's like a couple of voting that has already happened. So this the voting, whatever you see, that is as part of the migration step. We kind of add few dummy data here. After adding the dummy data, like you can pretty much go ahead and do things like whatever the different voting that you want, you can pretty much do that. And in real time, this is going to like kind of reflect on the UI. So what is happening behind the scene is this application is using something called as subscriptions. So if you see, if you go back to the Hasura graph and the GraphQL JS file, there is like a subscription query that we are going to run. So we can go ahead and run this subscription query in the GraphQL. You will see whatever the things that we are seeing as part of the UI. can be queried here as well. So let me do this and start the subscription. And as and when there is a new OAT that comes in, there will be like a new data that's going to get added here. That is basically based on the live subscription. As you can see, like there is a new data that came here, number of votes for React. So the one thing that we want to call out is the GraphQL subscription that is available as part of the GraphQL API works perfectly fine with YugabyteDB as well, and it is very performant, as you could see, with Hasura cloud instance, and which is configured with the Yugabyte cloud instance. So the number of steps that is actually needed for getting started with this entire stack is very straightforward. There's like few things that you would have to do, like retrieving the connection information, and that's the only step which is going to be manual. And rest of the things like applying the migration, everything is part of the scripting. And that's how easy it is for somebody to get started with this entire stack. Okay, cool. I'll let Pratt continue with the presentation while I'm going to come back after his presentation with setting up this cluster. Cool. Let me stop sharing.
Thanks, Nikhil. All right, everybody. Yeah, you haven't gotten it going yet. Just keep working on that. You can get it set up and going. I'm going to do just a bit of the talk about performance tuning, query tuning with Hasura and Yugabyte. What are the things that I like to look at? How do you tune queries, and what are you looking for to do? You get some bad queries in there, things are taking a long time. It's like, okay, what do I do, right? So first thing that I say is, where do we start? And I like to kind of look at what's performance tuning versus query debugging. Right, so performance tuning is, okay, it's more OS level debugging. We're looking at statistics like memory and CPU. How are those queries affecting the statistics above? Do we have enough horsepower for these things? Do we have enough cores? Do we have enough memory? And then we got to see, do we maybe have some hotspots? Is our partitioning not good enough that we're not randomly distributing the data enough? And then query debugging and tuning, right? That comes down to, so how do we identify slow queries in the database? How do we analyze the slow queries? What are we looking for when we do analyze them? Once you found it, what do we do with it? So that's going to be what I'm going to talk about over the next few minutes. We'll take a look at some of it. Some queries we'll kind of run through, specifically using this poll application, analyzing some of the queries. What am I looking at? What are we looking for? How do I see it in the database versus Hasura? So let's kind of keep moving. So for Hasura, they actually make it quite easy. It's just a little button there, right? It's the analyze button. It runs a similar, it's the equivalent to the explain analyze that you would run in like Postgres or in Yugabyte. And you can see it right there on the Hasura console. I have it up here. It's this guy. It makes it nice and easy to be able to, do the first steps towards initial analyzation. And, this is kind of what it looks like. This is what it looks like. You get generated SQL, you get the execution plan. We're going to go through a bit of kind of how to look at these. But on the other hand, how in Yugabyte, in the DB itself, you can also find this information. We're going to go through and look at how you do it in the database. We'll run the similar queries that I'm going to run and that I'll show you in this presentation, and we're going to have a look at them. So in Yugabyte, if you're familiar with Postgres, there's the pgstat statements. It collects all the information about queries that are run against the database. I like it a lot. I use it all the time. Like I said, if you've been doing query tuning and stuff, you're probably familiar with this because it's really important. And then the queries that I run against them to find the slowest queries are these. One, I do a PG stat statement reset. So that way we clear out the table. So that way, any of the slower queries that are coming in, we don't have to sift through too much. We can just kind of run the query we want, find those, pick them out, and then start doing our explains or our explain analyze plans to take a look and see where we're spending our time. Because that's kind of the most important part about query tuning is where are you spending your time? So we have our platform, just throwing this plug out there for enterprise people. We're focusing on cloud today, but we have a slow queries tab. Sorry, that went a little quick. We have it, slow queries tab in our platform. It's great. Pretty much does the same thing as PG stat statements. Here's kind of a brief look at it, but we'll keep moving on here. So, we've identified our slow query. Now what do we do? Let's look at an explain plan. I did a very basic kind of example that we can kind of walk through, right? So we have a table, foo, we inserted a row, and we do a query, right? We do explain select star from this table. So what you see is our query plan, and you can see we do a sequential scan on that table. We have a cost, we have the rows, and we have a width. So what do these all mean? So for cost, the range, the number is because it shows the cost for starting the operation row and the cost for getting all rows. And by all, I mean, returned by this operation, not all on the table. In this instance, since we're doing a select star, it would return all. But if you were doing something else, right, it would just be the number returned by that operation. So for the starting cost, right, we have a sequential scan. Now, in this one, we have a sequential scan, which means there is no actual starting cost because we just sequentially scan through that table. It doesn't have to go find anything. We're just going to start at the top, go through it, give me everything. It's pretty basic. The rows itself is pretty self-explanatory, right? It's the number of rows for set operation. And then the width is the Postgres idea on how many bytes, on average, there are in a single row returned from a given operation. So since our fake table just has a single int column, it's stored as 4 bytes. So we can see that width as 4. So yeah, pretty basic thing here. We'll go on to the next one. We kind of now move into an explain analyze. This is, I think, a little more important because, as I mentioned before, it's showing us where we spend our time. So we can see from this one, I have a slightly different table that has set up. You can see we're doing a limit. So we start with our limit. There is no cost because we are doing a sequential scan. We limit for those 100 rows. We are going to say our width is 608 bytes. Could not be. And then you can see down here, we show where the actual time is, right? So that's kind of an important part. Like I said, it's a really basic query. It's just to kind of get our understanding of what we're looking at. So it could be that if this isn't, I mean, obviously this is quite performant, but if we're looking at something else, a sequential scan may be something where we're going to start looking to add an index to help speed that query up. So let's look at something maybe a little more complex, not too crazy yet. But we can consider the following tables. I like beer, so we have a breweries and a table. So we have the breweries, where that could be in Denver, where we have a lot, where I live. And then we also have maybe their beers to kind of look at, what the beer is, some of the statistics about the beer. kind of interesting stuff if you like that. If not, here it is. So let's look at this. Let's look at the following query, right? So we have an explains select the BE name, beer name, the brewery name, from beers, breweries, where the brewery ID equals, and then we kind of do a little join there. And we can see that, we do this nested loop. We have a sequential scan on our beers table, and then we have an index scan on our breweries. So this query plan shows that the execution plan the optimizer came up with is based on its knowledge of the data. The query is not executed, right? Because it's an explain. We're not actually running this query. It does not show any timing or anything, right? Just kind of gives us a general idea of what's actually happening. But it does show some important statistics, right? So there's no startup cost again, because here we're doing our sequential scan. We can see also that the nested loop gets 1,000 rows, which is interesting. And a nested loop takes a single row from the first row source, the driving row source, and matches that with the second row source, probing row source going down until the driving row source is exhausted. So here we can say that a sequential scan is performed on a beer. There's no startup cost. Total cost is 100. The row source must produce the 1,000 rows to have that NL row source get 1,000 rows. So just kind of, that's how it goes. But then we do an index scan. That's for 4 other breweries on the index breweries PK. So each probe of this row source costs 0.11 and returns 1 row. So that's not where I wanted to go next, but I thought that was just kind of an interesting way to look. If we were to go and run this with an explain analyze, right, it's going to then actually do the timing, show us a bit more information about it. Maybe we can dig into it a bit further. But now I'd like to kind of go back to our polling application and do it, with you guys here on this webinar here. So I have it set up as well. It's pretty much the same one that Nikhil had set up. So I have our cloud instance here. This is our Yugabyte cloud, the one that you guys can go sign up for. I've done most of we already kind of have it all set up, so we won't need to do much. I just wanted to kind of show you guys this again. But we're going to go ahead and launch our cloud console, which I think is kind of nice because it'll just connect us to our database. And, we can start kind of going through and, running some of those queries. So I just need to grab my password. Unless I exited out of that. 1 second. Okay, so we have our password, and now we are connected to our database, right? You can see the databases that are here. We can see what tables, right? Sorry, not DN. You can see the tables that we have. You can see, our schemas. So you can interact with your database pretty easily here through our cloud offering. So if we go back to our presentation here, and I run back just a few slides, we can see so we have these queries. So let's say I run this right now. So if I run this one, because we can just go ahead and do that, what are we going to get? Oh, that looks pretty ugly. If you're maybe not familiar with working with databases a bit, we'll just want to throw on our extended display. We'll just do a /x there. It's going to make it a little bit easier to view. So now we can come back in and say, okay, here's all the queries that have been run against the database. A little bit easier to look through them. Now, it's not the easiest, right? But we can kind of say, okay, what are the queries here that have been run? What are they? We order them by time, so that way we can see down here. We select all of these, but we order by the total time descending, so that way we know what's taking the most amount of time. So if we come back and reset, we can go run some queries and take a look. So I don't have the permissions to for it for the moment. I'll check on that one. So I'm not going to reset it, but we'll just keep moving on here. So if we go and run it, say we want to look at the queries in Hasura rather than the database. We'll just kind of pivot to that one. We can see we're back in our GraphQL. Let's grab a query. We'll just get the full query here, and we're going to go run it. So we can run that, and we see our poll, right? This is the poll that's going on, favorite framework, but now we can analyze. This is interesting. So if you're familiar with Hasura, it kind of transforms your query into its query language that it'll then run against the database. And here it is, right? This is the generated SQL. If we were going to go back to our pgstat statements, you'll see the same exact query in the database. And you can see here our execution plan. So we do an aggregate, we limit it, we have a nested loop left join. We do our sequential scan on our poll, right? We can see our cost is nothing. We have our 1,000 rows. It's kind of what it does the default. And then we aggregate, we sort, we do another sequential scan on a different table, and then we send all that back. Now, it's the thing that I think a lot of people run into is this is not easy to read. It's not easy to kind of work with. And so some of the things that I've done is what I like to do is I try to think of, okay, what am I trying to do? And what data am I trying to pull back? What tables do I want to do? And I might actually go create that SQL, right? So if I come in here and I say, oops. So if I said one of these different tables that I wanted to kind of look at, I would think about writing the actual SQL to get the data that I want. Run that a few times, see how it looks, see if it's bringing back what I want. And then one of the things that I like kind of about Hasura is you can actually go and create your own SQL and create your own functions. You can track it here, right? And so if I think about, what I want, when I can go run it here, or, alternatively build it here in the Explorer, which is nice because you can just kind of click on whatever you want, get it to come up, run those. But they're not always going to be that performant because as you click on it, the way it translates may not be the best way for the database to access that data. So being able to run these analyzes to take a look, right? We're going to look at these execution plans to see what it's doing, try to see where we're spending our time. And then back here in the data, like one of the things you can see is this one is a function. So if we look at the modify, you can see the actual SQL. And this may look more familiar to maybe some of the DBAs here because it's basically doing, just regular SQL work. But it still will take this and transform it into how Hasura wants it to look like going against the database. Kind of the poll results here as well. This is going to be another function that it looks at, and it does these left joins on these different tables. Kind of we could see from kind of the API, right? We look at the poll, you can see. We look at the analyze again. You kind of see we do those joins. So we do that nested loop left join here. And so let's take a look at like a different one. So if you take, let's look at the results. Let's see who's kind of done it. So let's keep clicking on the wrong thing here. And our poll ID we have there, right? So we can just say, do this. All right, so let's analyze this one. Now we can see we have kind of a much bigger execution plan. You can see the generated SQLs a little bit more. And so if we come down, we can see we do our function scan. We do subquery on our poll results, on aggregates through. We do this nested loop join. As I remember, it has to go all the way down to we start driving down through this execution plan to try to find, the data that we need to pull back. So we can see in some cases, we'll do like an index scan. This is great, right? Indexes are very fast, very performant, especially within Yugabyte. Here we do a sequential scan, and we kind of move it all the way down. And then, this is what, when I'm looking at or when I'm talking with customers, these are the things that I go to look at, right? The execution plans, these actual queries, they are, a little more difficult because if you wanted to then do like an explain analyze and see where you're actually spending your time, we would need to take this query and input our variables, right? So we have these different variables that you can kind of see here. We have to input them in, but you can run this against Yugabyte and we can go in and then analyze that query and try to see, where are we spending our time? Are we not doing an index scan? If so, are we looping too much on a certain part? Do we maybe need to change the join order? I've seen that work. In one case, I was working with a customer and the query was taking quite some time, and just moving the join order, we shaved off like 10 seconds off the query, which, it was really great. But this is kind of where I like to spend my time when I'm working with customers. And, kind of moving through this, and especially here, like I like to, when I've done it, create functions to go ahead and do what I want it to do. And it runs pretty performance because as you kind of look in here, if we were to go and create a specific function for, let's say, a table to pull back some data, and we want it in a certain way, you can run it here in our Yugabyte Cloud Shell, get familiar with it, get it running well, how you want to look, and then you can just come in here, throw that SQL in here, track it, and boom, you can use it. And as we come back, you'll see it in the API. It will be on this side. So I think a lot of these are really, really great features built into both Hasura and our Yugabyte Cloud that allow you to look at your queries, how are they performing, finding them, trying to see, okay, we have some poor performing queries, we can go find them. So yeah, I hope that maybe it's helped you. It's been kind of informative.
There's a question, Pratt, on the chat. So the question from Stefan is like, would the explain plan show the information related to sharding as data location?
It's not going to show it as sharding as data location.
Would that influence the query performance?
It could, right? So if you have something like a hot partition where you're updating a certain row or reading a certain row more often than others in a distributed system like Yugabyte, that may lead to some issues. So we would look at the table, and then we would actually want to look at how you're sharding the data to make sure that it's unique enough that we then we insert that data randomly enough around the cluster, because if you think about it, we have 3 nodes. It's not like you're monolithic. We go to Postgres, you have the one Postgres DB and you go down and you find it, right? When we shard our data around, we want to be as random as we can. That way you can get the full performance out of your database. So that way we're not just hitting one node constantly. So the sharding is data location. That one's a little bit trickier, but it's important, right? Because we want our data to be random and go around, kind of go around the cluster in a random manner. So that way we're not spending too much time on any one node, trying to just get data or update a certain partition, a certain row, right, constantly. We want that randomness so that we're moving around and utilizing all our nodes as best we can. Does that help answer the question?
Yeah, for sure. At least
that's kind of my spiel. I'm on the community Slack. You guys can ping me anytime. I'm happy to answer any questions I can. We also have some great community users on, who work with this all the time, that I've learned a ton from as well. So, feel free to ping us.
Yeah. On the other side, I was able to fix the connectivity issue. I think my password was wrong. So
I'll stop. I think I stopped sharing.
Yeah. So I think I got the right one. No. Okay, can you see my screen?
Mm-hmm.
Okay, cool.
Yeah, no, it doesn't show necessarily where the data is coming from. We are working on some features for more tracing, which will help us. If you're familiar with Cassandra, you can trace and it'll show you, what node you're hitting, or which nodes are you're hitting with your query plans. We are going to be adding that, I think, as a feature. It's just not quite ready yet on the SQL side.
Correct. Yeah, folks, one important thing is please remember the password. So the password I was using for one other database, that was the issue. So I fixed my connection string to use the right password and the right encoding, which actually fixed the connecting to the database itself. So once this is done, we kind of had skipped a couple of steps, which was running the Hasura, the migration itself. So running migration, Hasura provides a really good utility where if you go to the project and you see there is a folder called migrations, and inside that there's a config file where you have to update whatever the new console that you are creating, right? Or you had created. My console, it's called Hasura DSS Workshop. I'm going to just go ahead and update that here. And I'm going to update whatever the admin secret we had. Here, I'm going to just update the admin secret. And one thing we can do is run the migration command. You can see the migration command. It's called Hasura migrate apply. And as I said, the database name and whatever the name you select for connecting to the database on the Hasura console actually matters, and it needs to match. So that's why we named our connection string on Hasura console as Yugabyte Cloud Instance. So let me use this. And I'll say Hasura migrate apply. So this has to. I think first it checks for if there is any upgrades that are required for the CLI, and then it applies the migration steps. Cool. The migration got applied, and if we go back to the Hasura console, the data here. we should see some tables show up. Cool. It's called Hasura Cloud Instance, and we see all the tables that are required, and we just track it. Those are the steps that we kind of had missed. So if you set up your like one of the only important step that you had to know as part of this is, which is not specific, like which you might need to know for the other applications that you are building, like how to make the connectivity between the Hasura cloud instance and the Yugabyte cloud instance. The important thing is like the connection string you build. The connection string obviously requires the admin password and the hostname. Along with that, it requires SSL communication. So those are the three things that you need to be aware of when you're configuring Hasura Cloud with Yugabyte Cloud. Cool. That's all I had. I wanted to just do that. Oh, my screen. Yeah, like this is the thing that I wanted to just showcase. Like one thing that I was missing is the URL encoding that I was doing. So once I fixed that, I was able to do the Hasura migrate apply and do the Yugabyte cloud instance. The migration got applied. And we can go ahead and see all the tables and all the relationships show up. And one thing you can do is just track all these things. As I said, the one thing that you need to be aware of is the connection string formatting. Like few things you need to be aware. The admin password needs to match and the hostname needs to match. And you'll need the SSL connectivity enabled because Yugabyte doesn't work on plain cloud instance doesn't work on plain text. It has to be on SSL or TLS.
And yeah, I just want to point out that that same track is if you create your function. Once you track those things, it will then turn your SQL into what it sort of wants to run. So that's why you'll see a difference if you say, well, this isn't what I wrote. It changed that for you to work better with it. So, yeah, just wanted to reiterate that one.
Cool. Yeah, if we don't have any more questions.
I think we have 10 minutes left for questions or anything. I know we started a bit early, so.
Yeah.
Can I hang out for a couple minutes or ask questions or ping us on ping me on community or happy to chat.
Cool. Thanks, folks.
Thanks, guys.